Before we get started, I want to thank our sponsor, as always. The sponsor, OpenRaven. OpenRaven is the data security posture management company for security teams with modern cloud infrastructures, needing to locate and secure sensitive, toxic, and exposed data across clouds at petabyte scale. Enter our Steam Deck raffle, www.openraven.com/Valve Steam Deck. Winners will be notified after the event. As always, I will be looking for Q&A after the talk. Please raise your hand. We'll bring over the mic so people on YouTube can hear it. Or send in your questions. YouTube comments, Slack, we'll be watching. Thanks so much. Mike, please welcome Mike.
All right, thank you, everyone. So about me, my name is Mike Rima. I am a staff cloud security engineer at Gemini, and my job is to secure the cloud infrastructure. And throughout my career as a cloud security engineer, I built a whole lot of tools to either simplify or complicate this task. As for a bummer, there are no actual physical spaceships involved in this process. As a kid, I played the game Star Control on the Sega Genesis a whole lot, so that's the theme of this entire presentation. And later on, we're going to talk about what we mean by spaceships in this title. So other than the lack of physical spaceships, what is the real problem that we're trying to solve? Well, I'm a cloud security professional in AWS, and as a cloud security professional, I have a need to turn on security controls for visibility and auditing capabilities, as well as security enforcement capabilities. And I need to do this pretty much everywhere in my infrastructure, across all my AWS accounts, all my AWS regions at the same time. And this one is a bit controversial, and that is that I need to be able to address resources that are either brand new or pre-existing, right? Regardless of who owns it. If there's a security problem with a resource, I sometimes have to act really quickly to fix it, especially if I have it in a bunch of resources throughout my infrastructure. And I also need to be able to have a consistent, correctly configured security control rolled out. And that needs to be done in a way where there's a low cognitive burden that's easy for me to remember. As our infrastructure grows and things get added all over the place, that becomes more difficult for me as a security engineer to have to remember where everything is and have to rationalize how it's all configured. So making sure that that's consistent and configured everywhere correctly, that's going to give you the assurance that your cloud is secure and that you can actually sleep well at night. Let's talk about some math and assumptions, right? So let's assume you have 50 AWS accounts and you need to deploy some visibility tool across all of the regions in all these accounts. Well, by default, Amazon has 17 regions that are turned on by default. If you had to deploy a resource in all of those areas, that's 850 resources that you have to deploy right there. And as your infrastructure grows, that number grows as well too. So what are some solutions that Amazon would tell you, right? So one of the textbook answers that they say is, hey, use organizations. Right? And if you are a multi-account customer, which generally speaking, if you're using AWS in any real way, you're going to want to have multiple accounts. And if you're going to have multiple accounts, you're going to want to make use of this thing called organizations. It's definitely something you should use. And organizations has some good features. Like CloudTrail, for example, in organizations is great because you can turn it on in the orgs and it just rolls out everywhere and it's consistent, it's configured properly, it's beautiful, it's wonderful. You don't have to think about it. GuardDuty 2 works really well in that way. Of course, you have SCPs. Those are also wonderful. But that's basically it, right? Orgs doesn't really do a whole lot, and you wish it did so much more. And so then there's another textbook answer you might hear, and that is to use Control Tower or Landing Zone. And we'll briefly chat about these a little bit later, but these are basically recommended mostly for new customers of AWS. If you're an existing customer of AWS, it could be an extremely large lift to get on board with this, and it might still not fully solve the problems that you really care about. These are some use cases that I thought about that I've encountered throughout my career that orgs doesn't come anywhere close to touching, right? So a simple one is I need to roll out an IAM role in all of my accounts, but maybe in some accounts I need it configured differently. What if I want to build a centralized S3 server access logging infrastructure where I have all the log buckets created. I have every S3 bucket in my organization configured to send logs to it. And I have those buckets configured to send notifications to a log aggregation system to go and grab those logs and process it so I can run amazing queries against it. I've built that tooling in the past, not because of orgs, because orgs doesn't do this. Same for ALB logs if you wanted to do that for ALB logs. It's not going to help you there. Another one recently, and this is, I'm going to talk about this a lot throughout this presentation, is AWS Config. It's a great service. I love it. I use it extensively. And for config, you sometimes want to turn it on everywhere, but maybe you want to tweak how it's configured. Because the way config works is every time something changes, you get billed. It charges you on every time something changes. So if you have a lot of noisy changes, things like EC2 instance churn or ENI churn, stuff like that, you might still want to log your IAM rules or your security groups or your S3 buckets, but maybe you don't want to log the really noisy things that will jack up your bill. But maybe in some places you do want to log those things. And so having a place where you could turn that on everywhere and be very easy to rationalize how that's configured and guarantee that that's set right, that's super desirable. Orgs is not going to help you with that. Another thing you're going to want is an account index. Something that indexes all your AWS accounts. Something where you can very easily look up accounts by their ID, their names, their organization unit, what parents they have in the OU tree, by tags, by enabled regions. And you want this to be programmatic because as a security engineer, sometimes I have to do detection work where I have to write scripts to query my infrastructure to pull down information so I could see if something is affected by something, right? And I want to be able to have this proper source of truth so I know where all my accounts are and I can do this iterative sort of detection work. And other teams benefit from this as well, having a proper source of truth for all your AWS accounts. I will tell you, the orgs API is terrible. It's so bad. If you can avoid making access to the orgs API, please do. It's not great. We'll talk about that later. Okay, so what are some of the existing tools and approaches to address this problem space? Everyone will say, infrastructure as code, Terraform solves this problem, CloudFormation solves this problem. No, it doesn't. it just doesn't solve the problem that I need to solve on a centralized security team. And this is controversial because a lot of people really love Terraform, and I really don't. I don't understand why this thing is popular. This is the first job I worked at where I had to use Terraform in any proper professional way. And oh gosh, I hate it. I hate it so much. Gemini, we use Terraform, and we also use a tool called TerraGrunt, which is like a wrapper for Terraform. And this is not the tool to solve my problem. And the primary reason why is Terraform doesn't natively understand multi-account and multi-region, right? So the way Terraform works is you have a provider, and that provider is mapped to an account region pair. And then you define resources that are mapped to that provider. And so if you're working in the same account, same region, that's fine, right? You just declare all your stuff and you're good. But if I have to specify something to deploy in 6 different regions, I have to make 6 different providers and duplicate all the resources, and it gets kind of messy real fast. So the way that people typically make multi-account support work with Terraform is they explode the file system. So instead of having one Terraform template with all this stuff defined, they make a bunch of directories for account region pairs, and then they duplicate all these templates across all of these different directories, right? So you just explode your file system. And if you have lots of accounts, lots of regions, you're going to have a crap ton of all these Terraform templates all over the place. And then you're reliant on some CI/CD system to parallelize the execution of Terraform for all of it. If you don't have that in place, it's a pain in the butt to set up. And also from the purposes of cognitive burden, right? Like, where is this stuff? It's all over this file system path. And if I have to make a change maybe to like 12 different templates, but not the rest, gets ugly pretty fast. So this is a solution that kind of sucks at scale. I could spend all day talking about Terraform state, but I won't. I absolutely hate this whole concept. One of the big problems is I can't manage resources that are not in Terraform state. And so if there's some pre-existing resources, maybe they were made 5 years ago, no one knows who owns it, maybe it's safe to delete, but I don't know. All I know is if there's a security misconfiguration, I need to fix it to protect my infrastructure. But I can't do that with Terraform unless I first import it into state. And that's a whole process into and onto itself. Maybe it's part of someone else's Terraform state, so I can't modify someone else's Terraform state. And so I have to do this wild goose chase of finding, okay, where is this thing being managed? Who's managing it? I don't have time for that, honestly. I just want to write some code to quickly find it and fix it and be done with it. And other problems, right? Like drift detection and prevention is not out of the box with Terraform. I think last year they announced Terraform Enterprise has drift detection, but no prevention, right? So I want to be able to find a problem and fix it everywhere. This is not going to do that. There's a lot of work for me to make Terraform do what I want it to do, and it's not trivial. So let's talk about CloudFormation, right? So CloudFormation has this really interesting feature called StackSets. And StackSets has orgs integration. So that's cool. It understands multi-account. That's even better. And really nice is that it will automatically deploy to newly created accounts that get created. So this is fantastic. This sounds like it solves all my problems. And in fact, it's quite decent of a solution if you have to roll out an IAM role in all your accounts. Like there's no difference between how roles are configured. Just set up StackSets, will put your role everywhere. New accounts get created, it's there. So that's actually a good solution for that. Control Tower and Landing Zone heavily rely on CloudFormation. Heavily rely on CloudFormation as the basis of how they function. And that's part of the problem because CloudFormation has a lot of problems, as anyone who worked with it over the years would know. And one of the most notorious problems that everyone complains about is that it doesn't support everything. Now, Amazon has done a great job at improving this, but there's a couple of problems that you can't work around. AWS Config Recorders, it's supported by CloudFormation, but you can't import an existing config recorder into CloudFormation. So this is a problem for me because if I have sporadic config enabled at my environment and I want to start managing it through CloudFormation, I can't do that. There's no way of doing it. You have to delete it and recreate it to bring it in. That's not great. Another thing too is like CloudFormation has its own concept of state. You can't manage other people's resources. You have to do this whole import process. I'm still having the same problem I had with Terraform. The organization management account is not touched by StackSets at all. And Amazon keeps telling their customers not to use the management accounts, but the fact is you have to because sometimes Amazon does not support delegated accounts with orgs. So you're forced to use the management account. So yeah, you have to put visibility things and other security things there. So it doesn't do that for you at all. There is drift detection, but it's not good, and the drift prevention is non-existent. So yeah, it's like there's so many problems with this. It doesn't solve my problem. And so I throw my hands up in the air and say, screw it, I'm going to write my own scripts. And a common story for a lot of companies is people will just write some one-off Python scripts or just make some Bodo calls to implement some state that you want. That gets old fast if it's some quick and dirty script, so companies typically work on trying to productionalize that. And the way that typically happens is maybe you'll turn it into a Lambda function to run on some cron schedule to do that. And that would do drift detection and prevention, which is nice. So you just have your script run, and it ensures that the infrastructure state is always present. CI/CD is even better if you have that capability. Of course, if you are a company that uses Terraform or CloudFormation, you want to make sure you still work with those teams to make sure that their templates are still up to date and working properly. You don't just want to willy-nilly update people's infrastructure and cause problems. You don't want to do that. So don't be a jerk. Work with your teams. Make sure that they're still doing what you need to do, but I still need my own control plane as a security engineer to enforce the state everywhere. Also build something nice. Prior to Gemini, I worked at Netflix on the cloud security engineer team there. And we built this tool called Honeybee, which is not open source. And I discussed this tool very much in depth in my 2020 reInvent talk about closing the lid on public S3 buckets. So I did this whole exercise on solving the public S3 bucket problem at Netflix. And it's a great talk, if I must say so myself. Please watch it. And in this topic, I talked about how I solved this problem, and this tool called Honeybee was instrumental for allowing me to do that. And what we did is we wrote a bunch of Lambda functions, and we made it very parallelizable, so we can run these workloads across our entire infrastructure very quickly. And we built a platform that allows us to build capabilities very easily by taking a lot of the account resolution logic and tasking logic, and we made that very code reusable so that we can rapidly add capabilities, make lots of Google templates, and have very declarative language around which accounts to run in, which accounts not to run in. Simple, easy to read YAML. And this allowed us to very quickly add capabilities. And this did drift detection and prevention, and we had CI/CD. It was great. Now that I'm at another company and I'm facing all the same challenges, I tried so hard not to rebuild this tool. I really need the ability of running a payload across my entire infrastructure and just have it do all the work. I could not get this done with CloudFormation or Terraform. And as much as I resisted not to do this, and all my coworkers will tell you, I tried so hard not to redo this, I threw my hands up in the air and said, screw it, I'm rebuilding it. I can't do it anymore, I have to rebuild it. So I did. And that is the introduction to Starfleet. And this is where the spaceships come in. So what is Starfleet? Starfleet is a solution to the gaps in AWS organizations. It is whole infrastructure automation for your cloud security assets. I open sourced it. You can download it. I'm not rebuilding this tool ever again because it's done. Okay? It is a clean room rebuild of that tool that I had at Netflix that I loved so much and I couldn't live without. So I rebuilt it from scratch and open sourced it. You're very welcome. What isn't Starfleet? I'm not recreating Terraform. I'm not recreating CloudFormation. I just care about the cloud security specific resources that I need to do my job effectively. This is also not aimed to replace tools like Cloud Custodian or Config-Rules. Right? These are more policy enforcement tools where you want to define some policy, maybe misconfiguration detection, and it gets found and corrected. You can do that with Starfleet. You can absolutely do that with Starfleet. But the primary purpose with Starfleet is to place the things you need where you need them consistently as your infrastructure changes automatically. I have fancy docs. I spent a lot of time writing them. Please read them. Some guiding principles. The most important guiding principle for me: control structures like loops and if statements belong in code, not templates. I can't tell you how many times I look at Terraform pull requests that come in. I see greens, I see reds, I see a bunch of braces and square brackets and all sorts of if statements and loops, and my brain turns off every time I see that. I'm like, ugh, okay, what is this thing doing? I have to really think about what's going on. I don't want to have to do that. Stuff that's really complicated like that should live in code. I want to see this abstracted away from users. Other guiding principles. We want to have eventual consistency, and we want to make things idempotent as much as possible. So if there's a failure, it should just retry and then succeed on the retry. And we want to be stateless as much as possible. It makes things easier to write and build out and expand. I like serverless development. This is a serverless tool. But if you've built serverless tools over the years, you'll know that it's not great to debug serverless tools. So the way that I get around this is I try to use CLIs as much as possible. So I add command line interfaces to all the plugins as much as possible that would run locally what would typically run in the cloud in Lambda. And this is kind of the equivalent of like a Terraform plan or a Terraform apply if you were to run that, but for your own local workers. So if you are having a problem, you simply pop a breakpoint and you can run it and see what the issue is. Also, anyone who knows me knows I'm obsessed with unit tests. Absolutely obsessed with them. And right now I have 100% test coverage on it, and I will do everything I can to make sure that is the case. Because remember, this is code that can run everywhere in your infrastructure, so you want to make sure it's as bug-free as possible. Lastly, we don't want to be a noisy neighbor. We have to describe our infrastructure state to know what we have to do with it. I like to use AWS config as much as possible because config keeps track of changes as they happen, and it's relatively current, so I can query that to get a decently stable state of what my infrastructure looks like. And you don't want to make tons of API calls to other AWS services because doing that could get you rate limited and cause all the tenants in your account rate limited. You don't want to do that. Don't be a noisy neighbor. So use config as much as possible is another guiding principle. So here's the general architecture. Starfleet is a very powerful tool. It can reach into all places of your infrastructure, so it needs to live in a very security-sensitive AWS account. And we'll look at each component individually. I mentioned before that we have YAML templates, right? Simple to read YAML templates. Yeah, these YAML templates, these are templates. These will define the desired infrastructure state you want. They live in an S3 bucket. In the middle, we have two important components. We have an S3 bucket that holds a big JSON file. That's your account inventory. The account inventory is generated by Starfleet, and what it does is it queries that orgs API, that annoying thing you don't want to have to do because it's annoying. I did all that work to get a full inventory of all your accounts, the OU tree, what tags there are, all that good stuff, and I dump it to a JSON file. And you can share that JSON file throughout your entire company, and that's a good authoritative source of all the AWS accounts in your organization that you can do programmatic things with. Well, that's important because we have this other component called the Starbase. And the Starbase's job is to take a template. Template will define which accounts and regions to operate in. It looks at that account inventory and says, okay, who am I going to task and how many tasks do I need to make to get this desired infrastructure state implemented? And it's going to task these workerships. These are just Lambda functions. We call them workerships. And the workerships is going to receive your payload template, and it's also going to receive some metadata about which account and region to operate in. So the Starbase is going to task a bunch of Lambda functions to run with the account and region context so the workerships can do their job. And the way they do their job is in every single account, we have stack sets create an IAM role that the workership can assume. So the workership knows which account to assume into. It assumes the account, it gets the credentials. It then implements that payload's desired infrastructure state in that account. And so that gives you the drift detection and prevention everywhere in your infrastructure, which is great. And the way it gets invoked is one of two ways. We have an event bridge timed events. This allows us to do cron scheduling, so we could have workers run daily or hourly or every 5 minutes or whatever cadence you find desirable. And we also have a template S3 bucket, which I mentioned earlier, but the bucket has bucket notifications configured. So every time we put a new version of a payload template to S3, that's going to kickstart the Starbase to then task the worker with that template to go everywhere and implement that desired infrastructure state we want. So this gives us CI/CD capabilities as well. For the code architecture, everything is a plugin. I'm very big on writing lots of plugin-based things. Lots of code reuse everywhere. I'm big on object-oriented principles in Python. So you just subclass things and you get all the capabilities for free. One of the things that we also make use of is Marshmallow. That's what allows you to define the payload templates. Lots of code reuse. You subclass, you get all this wonderful stuff for free. The account index is a plugin. You can either use the one that I ship that describes the orgs API, or you could use your own. As long as you implement the methods, you're good. Starfleet will happily accept it. And for CLIs, you make use of the Python click library. And I have a bunch of code that you can simply copy and paste and reuse, and that lets you rapidly add CLIs very quickly and easily. I added a bunch of other niceties. I added AWS Secrets Manager support. So if you have to talk to secret stuff, you can do that. And I also introduced Slack alerts recently as well. So I've been working on this since January, and I've been doing all this work. This is all boilerplate code that you would have to do yourself, and I did it for you. So you get it for free. And there's 3 types of workloads for Starfleet. So the first type of workload is what we call a single invocation. Sometimes you just want to run a Lambda on a cron. And this lets you basically do that. So this is a workload where I don't need AWS accounts, region context, just run a Lambda function. That will happily do that for you. If you need to operate a worker for every single account, you can use the account type worker, and that will provide the account context to the payload that the worker receives so it can do its job. And then the last one is an account region payload, and that lets you task a worker for every account in every region pair. So that spins up the most Lambda functions. That lets you have full infrastructure-wide implementation if you care about regions as well. We mentioned before the Starbase in the middle. That's the heart of Starfleet. And it will find the associated worker that is supposed to respond to that template and that triggering event, and it will task it accordingly. Anyway, it tasks things is that each worker has an SQS queue, and that queue is configured to invoke the worker. So the Starbase will put lots and lots and lots of Lambdas, payload YAMLs onto this queue, and then SQS triggers the Lambda functions to run. And there's also a dead letter queue configured, so if there's a problem, it gets put in the DL queue and you can assess it later. The worker ships, they're just Lambda functions that run Python. They do whatever you want them to do. So you can make it do whatever, and it will do it. Very important capability is the account specificity. This is what I think makes Starfleet really important. This allows you to define the accounts that you want to run in or not run in, and the regions you want to run in or not run in. Exclusion always takes precedence, and this allows us to reference accounts by very human-readable concepts, right? So we can reference an account by its name. We can reference it by which organization unit it's a member of, by tags, by IDs, and we could just say, hey, run in all the accounts, and the Starbase will take care of it. Lastly, there's this thing called the operate in org root. This is a safety flag that we add. If you need to operate an organization management account, it's a security sensitive account, you don't typically want to operate there, you specify this flag and that lets it operate there. Here's what this looks like if you want to run this everywhere. If you want to run a payload everywhere, you say we want it in all the accounts, all the regions, and operate in org root. Very simple. I can see this and see, okay, I know exactly what this is going to do. We could be more specific and say, hey, you know what? Only run in these accounts in these regions. And I can also throw some exclusion logic in there as well. So on the one on the right, we're going to run in every single region, but we're not going to run in US West 1. So I can look at this and very quickly see what this is going to do and what it's not going to do. Right now, since I only started working on this since January, there's 3 worker ships that we have that we've open sourced. The first one is the account index generator. That's what does all the orgs API calls for you to get the list of all your accounts and dumps that to the inventory JSON file in that template, in that account index bucket. We also have a worker ship to enable AWS config everywhere. And we also created one that will sync a GitHub repository with S3. This is a very common pattern in AWS, where a user wants to have their Git repo reflected in an S3 bucket. And what this will do is we have this set to run every 5 minutes, and this actually synchronizes a GitHub repo with all of our Starfleet templates, and it syncs it with that template S3 bucket. This is what enables CI/CD. So when we click merge, this will upload that to S3, and that kickstarts the Starbase to task the workers to get the job done. In the very near future, I'm going to add support for IAM and a bunch of S3 related things as well. Here's an example of using AWS configs worker for this. So it might be hard to see in the back, but on the left-hand side, we specified that we want this to run in every single account in every single region. And by default, we're going to configure every account in every region to have AWS config log every single resource type. However, we also want to define some overrides. So on the left-hand side, we have the ability of specifying a list of overrides. And in this case, we're going to say that in the super special account and US East 1, we only want to log roles and buckets and nothing else. And this allows me, with one YAML file, simple, easy to read template, specify how everything in my infrastructure should be configured for config, and I can override those configurations where I need to. This is extremely useful. I'm going to kind of showcase how Starfleet works in action just by talking through it with screenshots. So we have a template S3 bucket configured to hold our YAMLs, and it has notifications enabled. So if we put a new version of a payload in it, it's going to kickstart the Starbase to go ahead and do the work. What we also have is a GitHub sync worker that's going to sync what's in GitHub with the S3 bucket. And this runs every 5 minutes. In one account, I intentionally misconfigure the config recorder in 3 regions. So I go into one account in 3 different regions for AWS config, and I tell it to stop monitoring a bunch of random resources. I then go to that template bucket and I delete the YAML that this uses. So I delete the template that the config worker relies on. Within about 5 minutes, I receive an alert in Slack. The GitHub sync worker saw that the YAML for enabling that template for config was missing. So it put it back into the bucket. Within about 1 to 5 minutes after that, the config worker runs, and it got spawned across every single account region in my infrastructure, checked all the config details, and it found that there were 3 regions that were misconfigured, and it fixed them. This is the type of automation I need to do my job. And unfortunately, orgs, it just lacks the capabilities I need to do all this stuff. Existing tools, in my opinion, don't solve the problem for me. So I built Starfleet so I could do that. Contributions are welcome, and thank you.
Room questions.
Thank you for the talk. So from my perspective, the problems that you have enumerated with Terraform and CloudFormation are perfectly valid. So it makes sense to go about on this. However, when looking at this, I'm concerned, like, do you intend to compete with Terraform? And like, obviously this is somewhat of an IAC tool. So do you intend to compete with Terraform?
No.
Or TerraGrunt?
No,
or
so basically this is, I need to have, say, config enabled everywhere. I'm a security engineer, I need this tool, I'll go ahead and do that.
So this is essentially sort of a guardrails-like solution, which is intended to enforce...
Like a guardrails, it's an IAC for security teams.
IAC for security teams.
Basically.
Okay, so you only want a portion of what Terraform...
Yeah,
provides.
basically,
Okay.
like, I'm not looking to replace Terraform or CloudFormation. If you use that, good for you, but for me, if there's stuff I need, where I need it, or I need to verify something, that's what this is for.
Okay, in this case, open question, you know, how to get the stuff that you have back into the Terraform if you're not going to compete, because
Sure, that's a great
indeed
question.
the regions and accounts problem.
Great question. So
Pretty
basically,
big.
the strategy is, right, internally I had to do this recently. I wrote some internal workers to fix some things that were wrong. And what I did is, there's teams that are managing all that. I first go to them and say, hey, this is a thing I need to fix. I'm going to write a worker to fix it. Can you make sure that the Terraform is up to date? So basically, you work with those teams while you're writing the worker simultaneously to make sure that you're not going to break their stuff. So they're going to update their stuff. They might be slow at rolling stuff out, But by the time they update their stuff and I get this thing applying all the changes, everything will be fine. So that's how we did that internally, and that worked really well. Yeah.
So second time you've built it, what's your favorite thing that you changed, optimized, added from previous lessons learned?
Great question. I think the account resolution logic. I spent a lot more time on that. When we built Honeybee, it was very stovepiped for internal ways of doing things. I like the fact that I have much more sophisticated resolution logic now. So now I can look at like orgo use and tags, which we didn't have before. So it's much more human-centric as opposed to just IDs and names of accounts, which we had to stovepipe in after the fact. Oh, I forgot this. I spent so much time in DaVinci Resolve figuring out how to do it.
With the worker model, have you thought about integrating with other open source tools like Custodian or like Terraform CDK to make it so that you don't have to write as much custom code per worker?
I thought about that. The problem with like the Terraform CDK is that you still have all the problems of Terraform, right? Like I still have to deal with state, which I don't have to here, right? Like, for example, using AWS config means I don't have to have a static file in S3 because that makes sense. Something that's changing all the time, that's always up to date, right? So that's one thing that I like about having the ability of not using Terraform. And so something like the Terraform CDK, it's like you're kind of like, you're just writing tools to make Terraform less crappy for the use case that I have to deal with. I did spend a lot of time trying to find ways to wrap things, but I just ultimately found that, you know what, I'm good at writing Python. I'll just write some freaking Python and get it done. So that's what I did.
Do you want contributions? If
Yeah.
so, what would be a good place for someone to get started?
I would love for like the CI/CD work. I want to have some validation on templates. So if you make a pull request that validates that the template is correct before you can merge it in. That's one that we had at Netflix, and I don't have it yet here. So that's one that I would love.
Any other questions? Thanks so much.
Yeah, thank you.